What is the specific problem addressed in the paper regarding the lost in the middle phenomenon?
The specific problem addressed in the paper regarding the lost in the middle phenomenon is the struggle of large language models, LLMs, to locate relevant documents when they are placed in the middle of their input prompts. This phenomenon hinders the model's ability to effectively utilize and capture relevant information from the provided input contexts, leading to decreased performance in tasks such as retrieval-augmented generation, RAG. The paper aims to understand the factors contributing to this issue, particularly focusing on ILM's intrinsic attention bias, which results in models demonstrating a U-shaped attention distribution with higher attention values assigned to the beginning and end of the input prompt. The positional attention bias leads to models over-relying on content at the beginning end of the input, regardless of its true relevance, thus causing the lost in the middle problem.
How does the proposed attention calibration mechanism work in mitigating the positional attention bias? Illustrate step by step.
The proposed attention calibration mechanism works in mitigating the positional attention bias by disentangling the bias from the model's attention and allowing the model to focus on relevant contexts based on their true relevance rather than their position within the input prompt. The process involves several steps. 1. Estimating the bias. The mechanism first estimates the positional bias by measuring the change in attention as the relative position of a fixed context in the LLM's prompt varies. This bias is quantified and then removed from the attention scores for a given query. 2. Calibrating attention scores. By removing the bias from the attention scores, the mechanism obtains calibrated attention scores across the retrieved documents. These calibrated attention scores are better correlated with the ground truth relevance of the document to a user query. 3. Improving relevance ranking. The calibrated attention scores outperform popular existing approaches for ranking the relevance of retrieved documents, especially in open domain question answering tasks. This improvement challenges the belief that LLMs struggle to capture relevant context embedded in the middle of inputs. 4. Operationalizing the calibration mechanism. The calibration mechanism is operationalized as a solution named found in the middle. This intervention leads to improvements in model performance on RAG tasks by up to 15 percentage points on datasets like natural question. 5. Validation and application. The calibrated attention is used to re-rank documents in an input prompt with respect to a given query. It consistently outperforms uncalibrated attention and other re-ranking metrics, demonstrating its effectiveness in locating relevant information even when it is hidden in the middle of the input. In summary, the attention calibration mechanism works by identifying and removing the positional attention bias, allowing the model to focus on relevant contexts regardless of their position in the input prompt. This leads to improved model performance in retrieval-augmented generation tasks, addressing the lost in the middle problem effectively.
What are the theoretical benefits of using the proposed attention calibration method in retrieval-augmented generation tasks?
The theoretical benefits of using the proposed attention calibration method in retrieval-augmented generation tasks include 1. Improved relevance ranking. The attention calibration method allows for the accurate ranking of the relevance of different documents within an input prompt. By removing positional bias, the model can better attend to relevant contexts based on their true relevance, leading to more precise document ranking. 2. Enhanced context utilization. The calibration mechanism enables language models to effectively utilize the full context window even when relevant information is hidden in the middle of the input. This results in improved long context utilization, which is crucial for tasks such as question answering and information retrieval. 3. Mitigation of lost in the middle problem. The attention calibration method addresses the lost in the middle phenomenon by disentangling positional bias from model attention. This allows models to capture relevant context embedded in the middle of inputs, overcoming the struggle faced by LLMs in locating relevant information placed in the middle of the input sequence. 4. Complementary to reordering methods. The attention calibration method can be applied on top of existing reordering pipelines to provide an additional layer of improvement. By redistributing attention values based on relevance, the calibration mechanism complements reordering methods and further enhances the model's performance in retrieval-augmented generation tasks. 5. Efficient solution. The attention calibration method offers an efficient solution to mitigate the lost-in-the-middle problem with off-the-shelf language models. It does not require extensive data collection or model tuning, making it a practical and effective approach to improving RAG performance in LLMs. 6. Consistent performance improvement. Experimental results demonstrate that attention calibration consistently outperforms uncalibrated baseline models by a significant margin, especially in scenarios where the gold document is placed mid-sequence. This consistent performance improvement validates the effectiveness of the proposed modeling approach in retrieval-augmented generation tasks. 7. Future research directions. The attention calibration method opens up future directions in understanding ILM's attention biases and their impact on downstream tasks. By addressing the positional attention bias, researchers can further explore ways to enhance the performance and capabilities of language models in handling long input contexts and improving RAG frameworks.
How are the experimental validation and testing conducted to evaluate the effectiveness of the proposed attention calibration method?
The experimental validation and testing to evaluate the effectiveness of the proposed attention calibration method are conducted through a suite of controlled experiments using the natural question dataset with a Vicuña 7BV1 5 to 16K model. The validation process involves verifying two conditions. First, that model attention increases as positional bias increases when the relevance term is fixed, and second, that model attention increases as the relevance of the document increases when the document position is fixed. These conditions are validated on 100 randomly sampled examples from the natural question dataset with 20 documents. The percentage of valid example pairs for both conditions is decently high, at 83% and 72% respectively, providing support for the hypothesis. Additionally, the effectiveness of the attention calibration method is evaluated by comparing it to other methods such as vanilla attention, query generation, and relevance generation, focusing on the most challenging scenario where the gold document is placed in the middle of the input prompt. The results consistently show that the proposed calibrated attention outperforms the vanilla attention by a large margin, demonstrating superior performance compared to other re-ranking metrics. This experimental setup and evaluation process showcase the effectiveness of the attention calibration method in improving long context utilization and mitigating the lost-in-the-middle problem in language models.
What were the main results achieved with the proposed attention calibration method in comparison to existing approaches on RAG tasks?
The main results achieved with the proposed attention calibration method in comparison to existing approaches on RAG tasks include significant improvements in model performance. The attention calibration method, named found in the middle, outperformed existing methods by up to 15 percentage points on the natural question dataset. Specifically, the calibrated attention led to improvements across two popular LLMs with different context window lengths on two RAG tasks. The experiments demonstrated improvements over standard model generation by up to 15 percentage points on the natural question dataset. The proposed calibrated attention consistently outperformed vanilla attention by a large margin, showing superior performances when compared to other re-ranking metrics. The results validated that the proposed modeling approach was effective in improving models' long context utilization, especially when the gold document was placed in the middle of the input prompt. Overall, the attention calibration method provided a complementary way to reordering methods to further enhance the current RAG pipeline, showcasing its effectiveness in improving models' context utilization and performance on RAG tasks.
What are the limitations mentioned in the paper regarding the proposed attention calibration method and its application in language models?
The limitations mentioned in the paper regarding the proposed attention calibration method and its application in language models include 1. Simplification of the mechanism behind positional attention bias. The paper acknowledges that the proposed hypothesis to model the positional attention bias may oversimplify the intricate and dynamic mechanisms that actually drive this bias. It suggests that there could be more complex aspects of attention bias that are learnable or adaptive, which the current model does not fully consider. 2. Computational overhead. The attention calibration method, while effective, introduces additional computational overhead. Specifically, it requires extra model forward passes to calibrate attention at each position, which increases the computational cost compared to standard model generation. The paper notes that this computational burden could be a limitation, although it aims to inspire future research to develop more efficient calibration methods. 3. Positional attention bias may be beneficial. The paper points out that while the proposed method aims to eliminate positional attention bias, this bias might actually be beneficial in certain contexts. It suggests that in specific tasks or scenarios, the natural tendency of models to focus more on the beginning and end of inputs could align well with the task structure or data nature. Therefore, understanding the specific task requirements before applying the calibration method is crucial. 4. The root cause of attention bias is unclear. The paper highlights that while it aims to understand the connection between the lost-in-the-middle problem and ILM's intrinsic attention bias, it does not definitively pinpoint the root cause of this bias. It suggests that the origins of attention bias in LLMs could be attributed to various factors, such as the distribution of pre-training corpora, the transformer model architecture, and the optimization process. Further research is needed to delve deeper into the origins of this phenomenon.